Hello, cutie patootie math angel. Welcome or welcome back. This is Decaf-Math. I hope that you're doing well. As you can see here, today we are going to be doing some glow-in-the-dark math, which I think just looks really cool. Shall we just collectively go, ooh, ah. This will be quite fun. And in particular today, I'll just be chatting about a little shortcut that can come in handy when we're solving some algebra problems that involve fractions, whether the fractions are in the coefficients, which are the numbers in front of our variable here, or if the fractions are just in the constants, or both. So this is just one example. Here we have fractions everywhere, and we're just going to look at a little trick and then also build some intuition behind why it saves a lot of time. It's not a hard and fast rule or anything, but it definitely can speed things up a bit. So, as always, I welcome you to just sit back, relax, practice, or play around or review what seems helpful here. Otherwise, you can totally just zone out, space out, close your eyes, even drift off to sleep. That is perfectly okay. You won't get in any trouble, and there's never any pressure here. It's all love. All much love and encouragement. So let's get into it. In this case, we have, let's just read it out loud first. We have 7/10 x plus 2/5 equals 7/20, or 7/20, plus 3/4 x. So, first of all, what are we doing here? We are trying to solve for x. So what that means is, here we have one equation, because of this equal sign, and one variable, which is x, but x happens to appear here and here. So basically x is an unknown value right now, but what we do know is that whatever x happens to be, if there is an x that solves this, which is always kind of a given, is if there is a solution, then we know that 7/10 times that x plus 2/5 should equal 7/20 plus 3/4 times that same x value. So these are two expressions, and we should kind of understand what they mean. You still have to follow the order of operations, 3/4 times x, and then add this, and 10th times x, and then add this. So that's like the first step, and then we want to actually have those two values be equal. So when we solve this, we should have the same x value here. So our ultimate solution is to just say x equals blank, x equals what? And I have other videos on this kind of idea, the rules for moving different parts around and how we want to do this methodically, as opposed to just guessing and checking, because in this case we're working with real solutions and there's infinitely many real numbers. So you might get really lucky, but it's better to just logically walk through steps to actually get to a solution. So our goal is just to get to x equals blank, a number that satisfies this. So where's the trick? Here's our shortcut first, and actually normally I would do this longhand without the trick, just to show how a trick can really help, but in this case we're going to do the shortcut first and then build the intuition. So here the issue is that we have a bunch of fractions that we're dealing with, and it would just be much easier if we were working with all whole numbers. So this is what we're going to do. So the first thing I want to do actually is to do a little bit of a notation adjustment. It might be easy to see for some people, but I just just want to make sure we're conceptually very clear. I'm going to put this x here up in the numerator because I'm going to put this x as an x over 1, which I'm allowed to do because anything divided by 1 is itself. So x over 1 is x. The reason why I want to do that is because we have multiplication here. When we have a number squished together with a variable, it's multiplication. So that means we can just multiply the top over the product of the denominators. So this is actually just 7x over 10. So I just want to be extra clear with why we can just move this x up here on the numerator and it is the same thing. But I'm rewriting this on purpose because I want to make this abundantly clear that we have just these numerators and denominators here. Okay? So that should be alright. 7 over 20 plus 3x over 4. So I can just kind of scoot that up there for this reason, just putting it over 1 and multiplying. And the reason I want to do that is because now I can do my little shortcut. So you can see here we have all these fractions, but if I look at the least common multiple of these denominators here, 10, 5, 20, and 4, I can get rid of these fractions by multiplying them by this common multiple. Now it doesn't have to be the least common multiple. It can just be a multiple, any multiple, but it definitely saves time for it to be the least common multiple, just to keep these numbers and coefficients as simplified as possible. So what does that mean? We're talking about numbers that these numbers go into a whole number of times, as opposed to divisors or factors, which are numbers that go into these numbers a whole number of times. So positive multiples of 10, for instance, are, let me get a different color, are 10, 20, 30, 40, etc. Does that make sense? So 10 goes into 10 once, 10 goes into 20 2 times, 10 goes into 30 3 times, 10 goes into 44 times, etc. a whole number of times. And some positive multiples of 5 are 5, 10, 15, 20, etc. And multiples of 20 would be 20, 40, 60, 80, etc. For positive multiples, that is. And then for 4, it'd be 4, 8, 12, 16, 20, dot, dot, dot. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, etc. Okay, so we want to find the least common multiple, or at least a common multiple. So here you might notice that 20 is the least common multiple, and you might just notice that through practice and recognizing that off the bat. Or you can just kind of sketch out some lists here, but I promise it does get easier as you play around with this. But one trick is to just take the largest number too, which works in this case, is to take the largest number and just see if all of these numbers go into it a whole number of times. So 20 is a multiple of itself just because 20 goes into 20 once, which is a whole number of times. 10 goes into 20 2 times, 5 goes into 20 4 times, and 4 goes into 20 5 times. So 20 is a multiple of all of these and happens to be the least common multiple. So step 1, find the least common multiple of the denominator, of all of the denominators. And then step 2 is we take that number, so in this case 20, and we go ahead and we multiply by 20 on both sides. So I'll just do 20 like this, and then 20 like this. So a note there. First of all, I'm writing 20 with the dots like this for multiplication, because if I wrote x like that for times, then that could confused with this x. So whenever possible, just do multiplication with dots in algebra, or just squish them together. Like 3/4 x is 3/4 times x, right? So I'll just be extra clear that we're multiplying, so I'm putting the dots. The second thing is, the reason I'm multiplying by this on both sides is because we have this equal sign, which is always very underrated, as I say in my videos. It's actually extremely powerful, because just from this equal sign, it literally tells me that these two things are the same. But without that equal sign, I would know nothing about these two expressions. So you can have things that look completely different, but with the equal sign, it says that these are the same, which is just awesome. So because it's an equal sign, if I do something on this side, like multiply by 20, I can't just say like 1 equals 1 and then just multiply by 20 on this side and say 20 equals 1. It doesn't, right? If this equals this, then whatever I do on this side, I have to also do on this side to hold that the equality there. So that's why I'm multiplying by 20 here and multiplying by 20 here. The actually important piece of this is that in this case we're working with real numbers for x. So 20 times something is the same as something times 20. It's commutative. The order doesn't actually matter for these real numbers, but if you're trying to be really, really precise, you would do 20 times this equals 20 times this. But in this case, they're the same. So it's okay to write it this way, but do what you like. You can do 20 times this as well, okay? But the only reason why we have to write this out is because now we distribute this 20 over the addition, multiplication over addition, which works because we're working with real numbers again, which just means that we can multiply each piece by 20. And the key reason that we do this and why we pick the least common multiple or a common multiple to get rid of the fraction is because it indeed cancels. So if we do 20 times 7x over 10, if you're comfortable with this, you can just cancel like this. You can cross cancel and get to here. Divide by 10, divide by 10. If you're less comfortable with that, then you can do 20 over 1 and then do this cross canceling, or just do 140x over 10, but it ends up canceling anyway. And if you want to review cross canceling, I do have a video on that. That's kind of the point of picking the least common multiple in particular, is because these will cancel. So you just have 2 times 7x plus, and then you do 20 times 2 over 5. So remember, you're distributing this, so you have to do it for every single one. But 5 and 20 cancel because 5 goes into 24 times. And then equals, and then you have 7 over 20 times 20, but then the 20s cancel, which is nice. The denominator goes away. And then you have 3x over 4 times 20, and these cancel, so you get 5 because 4 goes into 25 times. So now you have 2 times 7x is 14x, plus 4 times 2 is 8, which equals 7, plus 3x times 5 is 15x. And now you have a equivalent equation to solve, but now all the fractions go away. So we have 14x plus 8 equals 7 plus 15x. Where we actually solve this, I just wanted to look at these side by side. So basically, whatever x solves our original equation should be the same x that solves this one, and the only difference is that we simply multiplied by the least common multiple. of all of these denominators and got an equivalent equation just by simplifying that out. And the reason we use the least common multiple again of the denominators is so that all of these bottom numbers cancel out a whole number of times, so that we just get all of these whole numbers to deal with up here. And that's just much easier to work with, because remember, with fractions, whenever we have, for instance here, if I were to move this 2/5 over here and then this 3/4 over here, I would have to do 7/20 minus 2/5. With fractions, we have to find the common denominator. We have to multiply the top and the bottom of this one by 4, for instance, to get the 20. Then we have to keep that denominator and subtract or add. In this case, it would be subtract the numerators, and we'd still get a fraction here, and then we get a fraction here for the coefficients to do 7/10 minus 3/4, and then we have to get that fraction and divide by this fraction here. It's a lot. It can be done. You just have to take more time to do it. But here, if I just multiplied by 20 quickly throughout, and as you get more comfortable with this, you don't even have to really show the 20 and the 20, you just multiply by each piece. But it's important to know why we're doing that. But as you do, you end up getting this. And this we can just do using our regular algebra rules. And you can take your time with this, but since it's not, the key part of this video, I'm just going to do it quickly. I'm going to move this over here by subtracting by 14x. So that's going to give me an x. And I'm going to move this 7 over here by subtracting 7. And if you want to show your work, you can do, minus 7 on both sides. Whatever makes you happy. But basically x equals 1. And we can check that. 14 times 1 is 14, plus 8 is 22. 7 plus 15 times 1, so that'd be 15. 7 plus 15 is 22. Yep, that should be good. I'm hoping that works here. So then you can just get your answer here. And ideally you then can, plug in x here and just check to make sure your answer is correct. But this should be fine. Of course, if you were to check this longhand, you still have to do all the fraction work anyway, but at least it saves you a lot of time, right? So, I just want to also point out, let's say you didn't come up with 20. So let's say you were doing this question really quickly, say for the SAT, standardized test or something like that. That's a little trick for the standardized test is, if you have no idea, you can just plug in some of the solutions to get some intuition. But let's say you have no idea, just pick any multiple that stands out to you. So, for instance, like I said, you could try out the larger number first and just see if all the numbers go into it. In this case, it does. But start with this one, because 20, 40, 60, for instance, because this is going to be the limiting factor in a way. And so, because, if you count from 4, for instance, like 4, 8, 12, 16, well, 12 is not going to matter, because anything less than 20 is not going to matter, because 20 is not going to go into a number smaller than it a whole number of times, if we're talking about positive multiples here. So you might not have noticed 20, but maybe you kind of look at this and you kind of figured, hey, 40 goes into, or 40 is a multiple, so 10 goes into 40, 5 goes into 40, 20 goes into 40, and 4 goes into 40. So you can just do the work, the same work of multiplying by 40 all the way through. You're just going to get a multiple of this, so you would get 28x plus 16 plus 14 plus 30x, so everything would just be doubled, which is still equivalent. It's just the numbers would be bigger to work with, so that's all. Just trying to point out that it is the same. So, if it's taking you a long time to search for a least common multiple, just go ahead and pick anything, because anything that gets rid of the fractions is helpful, right? So even if you don't see 40, you might see like 100. That's okay too. Just make sure you do this step by step, and just make sure to actually multiply all the way through. You want to make sure you're actually distributing out the multiplication. So I hope that this was kind of helpful as a little introduction here. Let's look at a couple more, but do them kind of quickly without all of the explanation. Okay, so now let's try 5 minus 1/4 x equals 7 minus 1/6 x. Okay, so again, we can do the x over 1 notation. Remember, x kind of belongs up here, x belongs up here. So if you're comfortable with this, you can just proceed as normal, but if you want, you can go ahead and write this as 5 minus x over 4 and 7 minus x over 6. And for that matter, you can even write 7 over 1 if that helps too. But really the point is you're wanting to get rid of the 4 and the 6 in the denominators in this case. And even in this particular case, just because we have only 2 fractions to work with, it's not that big of a deal to just solve this as you normally would and work out one fraction situation. But still, it does save time if you are comfortable with this little shortcut. So, the point is to keep shortcuts, and if they end up taking you longer, then there's no point in doing that. But let's go ahead and practice it. So what we're looking at here is a denominator of 4 and a denominator of 6. So what is the smallest number that 4 and 6 both evenly divide into? That's what we're first looking for. That's our least common multiple. So just from practice or experience, you might be able to just notice 12 right off the bat. If not, you can just write out some multiples of each. There's nothing wrong with that. At the least, you can always just do 4 times 6, which is 24. So in this case, that is a multiple, but 12 is smaller and happens to be the least common multiple. So we're going to work with 12 here, and this time I'm going to go ahead and write out the 12 times properly. So I would do 12 times this, and then also have 12 times this. And by that I just mean keeping the 12 on the same side. Otherwise you kind of have to explain the commutative property for multiplication for real numbers here. So it's okay though, either way, as long as you are consistent, you should be alright. So just remember that when you're multiplying by the least common multiple on both the sides, that you are doing it on both the sides again because of the equal sign. We want to keep it nice and balanced, so whatever you do on this side, you have to also do on this side to get an equivalent equation. And so now we just go ahead and distribute this 12. And remember, you have to multiply the 5 as well, so you can't just multiply the parts that you want. You have to do everything. So 12 times 5 is 60. 12 times x over 4. So if you found a proper multiple, the bottoms should cancel. The denominator should go away. So you have 12 times x over 4. And so this should cancel with this. And in this case, 12 divided by 4 is 3. And then here we have 12 times 7 is 84. And you know that off the top of your head because you either know your times tables or you've listened to some Decaf-Math videos, right? Where we do our times tables. And then here it says 6 and 12. These cancel. And 12, 6 goes into 12 twice. So here you basically get 60 minus 3x equals 84 minus 2x. And if you chose a proper multiple and did this all the way through, you should have no fractions left. And so from here, again, we're not necessarily focusing on how to solve this because that's just a different concept, but we can just do it for the practice here. We can just move this over here if we want to by adding 3x on both sides. And I'm moving it this way because I can see that negative 2x plus 3x is positive 1x. So this is going to be our x. And then if I move this over to this side by doing minus 84 on both sides, then I have negative 24. So x should equal negative 24. And so again, if our solution satisfies this equation, if we did all the math properly, it should be the same solution for this. So we can go ahead and check it. This would be, if we have negative 24, this would be positive 6. So this side would be 11. And then on this side we would have negative 24 times negative 1/6 is positive 4, and 7 plus 4 is indeed 11. So we get 11 equals 11, and that indeed checks. So our solution here would be x equals negative 24. But what would end up happening is if we did not do this little trick here, just, for intuition, we basically would have to move this 1/4 over to this side. And we'd move this 7 over here, so we'd have negative 2 equals negative 1/6 plus 1/4 x. So you still have to do fractions there. And again, when you add or subtract fractions, you have to find a common denominator. Multiply each on the top and the bottom to convert that. Keep the denominator and add or subtract the numerators. And then you're going to have to multiply by the reciprocal, this negative 2 by that reciprocal, to solve for x. And in this case, even with just 2 fractions, that's just a lot of steps. Whereas as you get comfortable here, you can even just look at this and multiply everything by 12 or even 24, and it just makes it so much easier. I think so anyway. So I hope that this is helping. I'll just look at one more question, and in that case, I'll just solve it really quickly now that we have these steps, and we'll leave it at that, okay? So I'll just show you one more, and in this case, let's just put it all together and kind of do a little speed round. But again, the point here is just to see one more example, and this isn't for pressure or anything. I just want to show you that it does save time, and also with practice it can go much quicker. It's just we've been breaking everything down. But here, let's say that we don't even bother writing the x over 1. Now you can kind of understand that the x belongs up on top, so we're really just looking at the denominators here. This is just 2 over 1, so we're just not going to worry about that. So we're just looking for the least common multiple of 6, 2, and 8. So we might check the largest number, 8 here, and 6 does not go into 8 a whole number of times. So 8, 16, 24. So the smallest common multiple would be 24. So I'm going to go ahead and multiply both sides by 24. I can do it here, however we want. I'll just do this like so. We're going to distribute this 24, and in this case I'm not even going to write it all out. So 24, 6 goes into 24, a total of 4 times, so negative 20x minus 24 times 2 is 48 equals 24, and then 2 goes into that 12 times, and then minus, and then 8 goes into 24 3 times 3 is 9, so 9x like this. And then you can just do your algebra stuff. So if I move this over here, it's positive 11x. And then on the other side, it would be negative 60. Then I just divide by 11, so x equals negative 60 over 11. And now I'm just hoping that we did that all right, because we did it pretty quickly. I'll just check later. But that's the general idea here. Pretty sure it's all good. But it's just all about, quick mental math at that point. There's no pressure, no hurry here. I'm just trying to show that as you get the trick down, it becomes second nature, even as we've taken time in our other videos to move, this over to this side and the steps involved and why we're doing what we're doing. It's all very important, but then when it comes to actually doing problems with practice, it can just be very quick and in your head too. So I just wanted to show you that you can get to that point as well. So take your time, whether you want to just take some time initially to walk step by step why you're multiplying by the least common multiple, or at least a common multiple, to just show yourself that it's just all about playing around with the math, and to just make your life easier working with whole number coefficients and constants rather than fractions. Do that, get some practice in with finding the actual multiples, and then also just make sure that you're comfortable distributing all the way through. And then other than that, it's just back to our basic algebra as well on how to solve for one variable or two, and of course you can extrapolate this for situations where you might have more than one variable, like I don't know, like this, and then having two equations with two variables, right? You can still do this trick for the top and then do the same trick for the bottom, or just multiplying the whole system by a constant, but that's a lot of common multiples to keep track of. But you can still just multiply across to get equivalent equations, and that can also simplify and just help you out. Like maybe the second equation doesn't even have any fractions or something, but this one can be simplified just by multiplying by 21 all the way through, something like that. Anyways, if you are asleep right now, I'm wishing you sweet mathy dreams. If you are going to continue on with the rest of your day, I hope that it's a good one. I hope that you enjoyed this glow-in-the-dark math. If you did, let me know, and we can do some more down the line as well. But otherwise, I'll see you around for more math and ASMR, or ASMR and math, or some combination of the two. We'll keep having fun. Thanks so much for tuning in. I'll see you very soon, okay?